Okay, I did a video on capacitance a couple months back, but now I think it's time to do a video on finding the equivalent capacitance both in series and in parallel. So let's just remind ourselves about what it means for something to be equivalent in terms of resistance. So if I have resistors in series, okay, then to find the equivalent resistance in series, I could denote that as R sub S is simply the sum of the individual resistances of each of the resistors. And if I had resistors in parallel, then the equivalent resistance in parallel would be 1 over the sum of the inverses of the individual resistances. So that is 1 over Rp is equal to 1 over R1 plus 1 over R2, and it continues on. Okay, so what we have to remember for capacitance is that equivalent capacitance essentially works the opposite way. If I want to find the equivalent capacitance in parallel, then I accomplish that by simply adding all the individual capacitances. However, if I'm finding the equivalent capacitance in series, then I denote that as C sub S is equal to 1 over sigma 1 over Cs. That is 1 over the capacitance in series is equal to 1 over the first capacitance plus 1 over the second capacitance, and so on and so forth. Okay, now I think we should take a look at an example. Let's suppose that I have a capacitor network that looks like this. So I have a point A here, I start, and then I have two capacitors in parallel. One has a value of 1 mu farad or microfarad, and then the other one has a value of 4 microfarads. Okay, and then I want to put this capacitor network in series with another capacitor that has a value of 4 microfarads. Okay, and then we'll terminate at point B. So I want to find the equivalent capacitance from A to B. Okay, well, first what we need to do is we need to find the equivalent capacitance between the parallel capacitors, 1 microfarad and 4 microfarads. And remember, when I'm finding the equivalent capacitance of capacitors in parallel, I simply add the capacitances. So over here, what I wind up with is C. We could denote this as C sub 1. It's our first capacitance in this A to B network. C1 is equal to 1 mu farad or microfarad plus 4 microfarads, which is equal to 5 microfarads. So now that we know that the equivalent capacitance of this right over here is 5 microfarads, I could rewrite this as the following. So I have A, I have 5 microfarads here, and then I have 4 microfarads over here. And then we'll terminate at the point B. Okay, so now I have capacitors in series. Now, to find the equivalent capacitance in series, I would have to write 1 over the equivalent capacitance in series is equal to the sum of 1 over the individual capacitances. That is, in this case, 1 over the equivalent capacitance in series is equal to 1 over 5 microfarads plus 1 over 4 microfarads. Now, remember that when we are finding the equivalent capacitance of two capacitors in series, there's a special formula that we could use. So if we know that C sub S is equal to 1 over C plus 1 plus 1 over C2, or I'm sorry, 1 over C1 plus 1 over C2, then if we multiply by the lowest common denominator, which is C1, C2, we find out that C sub S is equal to C1 times C2 divided by C1 plus C2. So it's the product divided by the sum. So in this case, we would have CS is equal to 5 times 4 divided by 5 plus 4 microfarads. And in this case, it would be 20 over 9 microfarads. So we have just found that the equivalent capacitance of this entire network, so we could write this as C from A to B is equal to 20 over 9 microfarads. I hope that this helped, and I will see you in the next one.